My name's Peter Shields, and on behalf of Airmet Scientific, I'm very pleased to welcome you to today's webinar, Advancements in Water Quality Measurement Technology, Sensors and Data Management Software. Today we're fortunate to have Romey Gilbert, the Sales and Support Manager from Seametrics, to present on the topic. Romey has over 21 years of experience in this field with INW and Seametrics, and I'm sure you'll find her presentation interesting and informative. So over to you now, Romey.
Hi, I'm Romey Gilbert, so I guess we're ready for the presentation. I hope you guys enjoy it and feel free to ask any questions. Thank you. And here we go. So this is a seminar on advancements in water quality measurement technologies. Some of the objectives will be sensor overview, common applications, application examples with site photos, so some of the places where sensors are installed, data acquisition and sensor software, sensor selection and consideration, and data management tools. Some of the common sensor parameters that people are looking for, especially in the environmental field, are water level and pressure, pH ORP, dissolved oxygen, conductivity, which also has TDS, salinity, turbidity, bromide, and chloride. We have different types of sensors that are out there in the market now. Some of them are recording devices, and within the recording devices there's premium markets where they're looking for higher accuracy, maybe store more data so that you have more data to look at, and advanced software features. There's also some of the more lower budget ones in some of the economy markets, which would be lower accuracy, less storage, and basic software. With the basic software, that's typically where you send a field tech out that you may not want them to change things around, and so that you can just have them go out and get the data that they need and move from there. There's also non-recording digital devices. These ones are typically used with telemetry systems that don't need redundant logging. They also are used for control applications like pumps to turn them off once the water hits a certain level, things along those lines. Or if you have an existing logger that you need to hook it up to. For us, the digital sensors tend to be like an SDI-12 output, which is what's very common. I understand that you guys use that in Australia as well. Some of the other non-recording devices are analog sensors. Those can be 4 to 20 milliamps out, as well as voltage out. Those are primarily used in pump systems or SCADA systems, or as a part of a PLC, or with Campbell type loggers. A lot of people ask why you would want to use a recording sensor over an analog sensor. The recording sensors tend to have a higher resolution and eliminate some of the uncertainties, because you only have one device. You're not necessarily looking at your resolution between several different devices. They detect more of the diurnal fluctuations, seasonality, weather, other foreseen circumstances. Parameters available today supplement a wide range of laboratory parameters, so you can actually use them as a checking point before you have to send something off into the lab. Less trips required to the site as you're actually recording it, and so that you have that information stored, and it helps make good decisions, making requirements for good data. Some of the reasons that you would use non-recording devices, for us, it's primarily for control applications. Those would typically be the analog sensors that you use to shut off the pumps at high-low levels and things along those lines. If you have existing loggers, you might want a non-recording device just because you don't feel like replacing all of your equipment out in the field. And which we see more and more people are going to telemetry and remote data collection, so that you're not sending any technicians or anybody out to collect the data. You can just sit at your desk and have all that information delivered to you. Sensors come in various configurations. Most of them are either come with cable or non-cable, depending on what type you're looking for. With level in particular, they have absolute or gauged units. PSIA is what we consider an absolute, so it's a non-vented unit. When you're measuring with a PSIA unit, you typically need to have some kind of barometric compensation, whereas a PSIG unit has a vent tube that comes up to the top of the atmosphere, or the top of your well or water information, and then it can, the barometric pressure actually goes down a vent tube, and that automatically calculates what your pressure is based on both of those parameters. When you're going with an absolute unit, as I said before, you have to have some kind of barometric compensation. In the past, that has required a lot of post data configuring, where you take it into an Excel spreadsheet, you try to figure out what that data actually is as you're subtracting the barometric pressure. However, now most of the post-processing can be done in various softwares that are being offered in the market. Another advantage to some of the gauged units is you can get direct read on the sensor. So if you want to walk right up to a well or right up to a river, all you have to do is take your laptop and look at that information. All non-recording sensors must be cabled in order to receive power and transmit data. They typically don't have any type of power in them. They're usually low power devices, so they don't require a lot of power being pushed into them. And like with the 420s, it's only 2 wires that are coming out that are sending that signal. There are certain water quality sensors out in the market that can be cabled or non-cabled, but there are 2 exceptions to those. If you have a water quality sensor in the market, they usually consume much more power than just a recording or just a pressure sensor. And so you would need internal batteries, and if you don't have those internal batteries, you would have to bring those cables out and plug them into some other type of supply. And also, if there's no internal logger capabilities, they must have cable to transmit the data, just like you would with anything else. There are several things that make sensors different when you're considering them for a purchase or for a particular site. Accuracy can vary. There's units out there that are 0.05% of full-scale accuracy. There's units out there that are 1% of full-scale accuracy. So it really depends on the application and what you're trying to achieve. Some of the units actually have thermal compensation, which especially for surface water applications, it's really important because as the water's changing its temperature, it will affect your pressure reading. The other thing is, depending on the type of elements that are in the units, long-term drift can be a factor, and the full-scale output is actually part of the accuracy. The technology has gone to various different types in the market over the past few years. Elements and electrodes have greatly improved, and there are various ones that you can choose from. They have anywhere from stainless elements to ceramic now. As far as pressure goes, electrodes have all types of different configurations, mostly of glass. Communication protocols, with the various different satellite systems, any type of radio devices, they all require different types of data coming out of them, whether it be Modbus, whether it be SDI-12, or simply just 4 to 20. Another factor would be the calibration frequency. Some units require calibration on a weekly, daily, monthly basis, whereas there are some out in the market that you can go 6 to 12 months without having to calibrate them. This is more for water quality. As far as pressure goes, there can be units out there that never need to be recalibrated again. Power sources are also something to take into consideration. A lot of units now have their own power on board, so you're not running different cords going to various different places. And installation methods are definitely another item to take into consideration when you're trying to look at the various different sensor types. Sometimes you have site constraints where you can't access the sensor, so possibly if you have a gauged unit, you're worried about desiccant, that might not be the best choice for that type of installation. There's some places that just have hazardous to get to. So if you want to try to eliminate, and for safety reasons, you might choose a sensor that could just send the signal back to you at your desktop. Some of the other things that make sensors different, some of them are you can service them in the field, other ones not as much. You know, there are units out there that you would have to send back to a factory to have the batteries replaced, or there are units that you can actually go into the field to replace them. There are definitely sensors now that you can do a manual calibration in the field, whereas in the past you've always had to send them in to be recalibrated. And you know, if you injure or damage a cable, there are definitely different types of sensors that you can replace the cables in the field fairly easily. Another thing to consider would be cost of ownership and life expectancy. They're moving more towards having replaceable batteries in the field now. At one time, more of your sensors that were out there, you would have to send it to the factory to have the battery maintained. General maintenance, calibration for conductivity probes, things along those lines. There's several sensor applications that we're used to dealing with, and I'm sure that you guys have seen them. There's stream gauging. Aquaculture is becoming very popular as we're moving to more and more fish farm type situations. Wetland survey, tidal influences, discharge monitoring. In the States, we have to adhere to NPDES codes, and so they're monitoring anything that's coming out of a factory, that's coming out of anything that might be producing into a water stream. And while they're monitoring that, they're looking at the max amount of pollutants that can be introduced as well. We have pretty strict laws over here in the U.S., and so this is all very important in their reporting. As you guys all know, that water is becoming a resource that we need to hold tight to us and make sure that everybody keeps getting it. With all the drought situations that are coming around, we have them in the States. I'm sure you guys do there as well. Water resource monitoring is very important. Site assessments and characterizations, we use that mostly if we're going in to be building housing developments and things like that. We want to make sure that there's enough groundwater, hopefully, to support those, if not what we need to do to bring the water into those places. We have both, you know, all sorts of remediation processes, both post-remediation monitoring and monitoring during the remediation process. Fracking, you know, they're checking all the waters to see if they're getting pollutants in them as they're going that deep. And then control applications where sensors are being used to kind of check up another system and make sure everything's functioning properly. Here we have some of our application places for monitoring turbidity. This particular photo on the left here is in Florida, and what they're doing is they have put in these cyclones that they're trying to see what the dust is doing into the stream here in the river, and so that they're taking these turbidity monitors and checking them. If you notice in the yellow, that's actually where they're supposed to be containing all the turbidity. So in this type of application, you would have a sensor over here before it and then one after it to see if any of the dust is making it downstream. We also do a lot of applications for groundwater remediation type sites. We do thermal remediation where they're actually heating up the groundwater and frying it, kind of basically boiling out any type of contaminants. We do those on a lot of our military sites that they can easily keep people out of, and then you put your sensor in there and you're checking the water and the temperature as well as other type of parameters. Another big one would be for tidal influences. Again, you know, we're comparing the sensors that are installed, and monitoring wells drilled inland to see what type of tidal influences, if they're bringing in salt water as they do that, if you're drawing down, if it's ever going to replenish itself normally, and if the tidal is just, as we go deeper and deeper into groundwater, you find that your tidal influences might be pulled in sooner, and so you're getting contaminations like salt in there. And, you know, you don't want that for drinking water applications. Water resource monitoring, again, this is a site that we have in Texas where they have hundreds of wells, and they're having such issue with droughting that as they're building, the more and more they build, the more they need to make sure that these wells are actually being recharged after they draw down. And in this particular site, there were several situations where they're not. So then they have to figure out, okay, are we going to use this water in irrigation systems? Are we just going to save it for drinking water, and other types of considerations? If you'll notice, he has a water level indicator in his hand, and basically that's just a sounder that you put into the water, and then once you hit the groundwater, it'll make a beep so that you know where to set your sensor. There's various different ways to retrieve your data. Manual retrieval of the data is pretty much what the industry have been used to up until the last couple of years. Well, I guess the last 10 years now, where you basically, go out, you take your laptop with you, or any other type of device. We're moving more and more to like not palms anymore. I just dated myself, but you know, your cell phones, tablets, things like that, and then you just retrieve that data going up to the well. In a situation where you're using a sensor without a cable, you'd have to pull the sensor from the well tank, whatever situation it was in, take off the cap that's typically on it and download it there. That's a lot of the reason why people do prefer some of the cabled sensors as opposed to just going with a non-cabled unit, because once you do have that the sensors down the wells, if they're incredibly deep wells, it takes some time to pull those out. Another reason that you might want to go with the cabled version is so that you can just do a spot check to see if that sensor is working without having to pull the whole thing out. All the industries are moving more and more to telemetry as we want to try to cut costs with sending people out to the field. We'd rather have the information instantaneous so that you can sit at your laptop or whatever type of site and have alerts come to you and then be able to look at the data at that point. We've dealt with 3 different types primarily. There's cellular, radio. I don't know what the restrictions are in Australia. We have 900 megahertz radios that we can have that are license free in the States. Anything above that, we would have to go through the FCC to get approval for them. And then satellite is becoming very, very popular. Sometimes when you're out there selecting a sensor, there's so many on the market, it's not necessarily an easy thing to determine what you want. So first off, you probably need to decide what parameters you need. Do you need water level, pH, turbidity? Are you looking at, you know, conductivity? Exactly what you need at that particular site. On this sensor right here, this is DO, which is another parameter that, especially in the aquaculture field, is very important. And then you would also want to take into consideration some of the indirect calculations, like if you need this to be alarming, if you're going to have a physical sampler coming in there as well, or if you're triggering an automatic sampler. The other thing to take into consideration is timing and event frequency. A lot of the water quality sensors in particular might have a little bit more time that they need to equilibrate before they can actually transmit that data back to you, or before it becomes you know, a usable number. Sensors also, between the different brands out there, need various different calibration times. Again, like I mentioned earlier, calibration can be done daily up to monthly, depending on what type of sensor you're using. Resolution also affects your accuracy, so that's another thing to take into consideration. And a lot of times there's only going to be a certain type of sensor or a certain type of data that we can collect depending on the agency that you're dealing with. Some of this other sensor considerations, some of the best practices and impact on QA and QC obviously would be the data integrity. Lots of the sensors are NIST traceable. I don't know if that's something you have there, but that is on our end. It is where we verify that all of the equipment that we use has been calibrated, that's within the standard, within its specs, so that we know that as we're producing sensors that they're coming out correct. Chain of custody considerations are also something, and audit trails with raw source data files. Data acquisition software is another one to take into consideration. There are various products out there. Some of them are a lot more complicated than others, and so if you're looking for somebody that, you know, I guess some of our, what we call hydrogeologists over here, they tend to want to dive into the data and they need more and more information. Whereas if you're just going out in the field and picking up some data that you're going to be delivering back, or you're just checking it, maybe you don't need to be able to look at the software in that level that they have to. And then you want to make sure that your sensor, if you have any post-processing modeling software, that it's compatible with that. There's several data tool managers or data management tools out there. There's tons of third-party software available now that's taken all of your data that will do graphs and stuff showing you exactly how that water is flowing. The ability to bring in different data sets can help see the whole picture and make better informed decisions. Again, when you're selecting a third-party software, you need to make sure it's compatible with your sensors. We have had situations where people go out and they buy a sensor from somewhere, software from somewhere else, and then they try to get it all together and it just doesn't work. I would suggest always trying that before you actually make your purchases. This is an example of some of the modeling software that's out. This one in particular is from a company called Groundwater. They're located in the States, and as you can see, it is showing you what's happening as they're pumping down a well and what's going on with the various different locations. And the red area is how the pumping water out of the well affects the entire aquifer, in which way the groundwater is flowing. And so in summary, sensors are needed, as we all know. There's a demand for accurate, reliable data so that people can make good decisions about one of our most valuable resources, which is water. Consideration in making selections, the right parameters, installation methods, and technologies to meet site objectives, and software, the powerful software that is available to aid in quick sound decisions making, and that can help you visualize what's going on without just looking at a water level or a conductivity level or a turbidity level.
AMET Scientific represents the Seametrics product range in Australia, so if you'd like any further information on these products, you're welcome to contact us. Finally, I'd like to thank Romey for her time.
You're welcome, Peter. Thank you guys for attending.